Hello students, hope you are fine and safe, and I think you have already completed with all three parts of acid, bases and salts and also the assignments given to you. If not, complete that acid, bases and salt and then you can take up the next chapter, that is electrolysis. Electrolysis is the fifth chapter in your textbook. So we'll study part by part and this is part 1. And the lesson of this, the chapter is given as a PDF file along with this video. Because you don't have the textbook, I've attached the PDF so you can get this chapter in the PDF file. To start with, electrolysis term can be split into two. That is, electro means electricity, that is flow of electrons. Lysis means breaking or splitting. So it is splitting of a chemical compound by passage of electric current. We'll study about the definition little later, because before that you have to learn a number of terms which you will be coming across in the definition. Some of the important terms which will be coming across the definition of electrolysis. The first one is electrolytic cell. It is a non-conducting vessel containing the electrolyte. So it's a vessel in which electrolysis is carried out. Now what is electrolyte? Electrolyte is a chemical compound which conducts electricity in fused or aqueous solution state. Fused or molten state. Aqueous means in water, solution made with water. So electrolyte is a chemical compound which conducts electricity in fused or aqueous solution state. The next term is electrodes. Electrodes allow the electric current to enter or leave the electrolytic solution. So there are two electrodes, anode and cathode. Anode is connected to the positive terminal of the battery, so it is a positive electrode. Cathode is connected to the negative terminal of the battery and the cathode is the negative electrode. Anion is negatively charged ion, therefore it moves toward the anode, which is a positive terminal. Cation is a positively charged ion, so it moves toward the cathode. Cathode is a negative terminal of the battery. You have learnt all the terms related to the definition of electrolysis. So now we'll learn the definition of electrolysis. Electrolysis is the decomposition of a chemical compound in aqueous or fused state by passage of direct current, not alternate current, resulting in discharge of ions as neutral atoms at the respective electrodes. Example, sodium chloride is an electrolyte. In aqueous state, it decomposes to give Na plus and Cl minus ions. The Na plus ions moves towards the cathode and gains one electron and forms neutral sodium atom. Chlorine ion moves towards the anode, loses one electron to the anode and forms chlorine atom. So there is gain of electron, that's reduction at cathode, and there is loss of electron at anode, and that is oxidation. So reduction and oxidation takes place simultaneously. Therefore electrolysis is a oxidation reduction reaction, that is redox reaction. So this is the diagram of a electrolytic cell where electrolysis takes place. The vessel is called as an electrolytic cell. So electrolytic cell is a non-conducting vessel containing the electrolyte in, here it is, solution state. X represents the electrolyte which is present inside the electrolytic cell. And you can see the circuit here, a key, a battery, and then it is connected to anode and cathode. Anode is connected to the positive terminal of the battery. Cathode is connected to the negative terminal of the battery. A bulb is attached to the circuit to show whether electricity passes through it. If the bulb glows brightly, then the electrolyte is a strong electrolyte. If the bulb glows dim, it is a weak electrolyte. If the bulb does not glow, then it is a non-electrolyte. So there are three types of electrolytes: weak electrolyte, strong electrolyte and non-electrolyte. I hope you understood the diagram. Electrolytic cell containing the electrolyte, that's a chemical substance which when electricity is passed through it, it dissociates to give ions. And these are two electrodes, anode and cathode, connected to the positive and negative terminal of the battery. The next is types of electrolytes. First of all, what is electrolyte? It's a chemical compound which conducts electricity in fused or in aqueous solution state and undergoes chemical decomposition due to the flow of electric current through it. So there are three types of electrolytes: strong electrolyte, weak electrolyte and non-electrolyte. The strong electrolyte allow a large amount of electricity to flow through them, and they completely dissociate in fused or in aqueous solution state, and the solution of this strong electrolyte contains ions only. So you have already studied in acid, bases and salt about strong acid, strong base. So they are all strong electrolytes. So all strong acids and bases and salts of strong acids are all examples for strong electrolyte. I've given a few examples here. Hydrochloric acid is a strong acid. Sodium hydroxide is a strong base. Sodium nitrate is a salt of a strong acid because it is formed from nitric acid. So there are many other examples given in your textbook. You have to learn all the examples. So all strong acid, strong bases and salts of all strong acids are example for strong electrolyte. Weak electrolyte allow a small amount of electricity to flow through them. Unlike strong electrolyte, their large amount of electricity is flow through them, but here only a small amount of electricity flow through them. They partially dissociate in fused or aqueous solution state, and they contain ions and unionized molecules. That means not all the molecules gets dissociated into ions. Some of it still remains as molecule, that's called as unionized molecules. A solution of weak electrolyte will have ions and unionized molecule in its solution. So all weak acids and weak bases and salts of weak acids are example for weak electrolyte. So you know all the weak acids we have studied. One example here is carbonic acid, weak base, ammonium hydroxide, and salt of a weak acid is sodium carbonate. The salt is formed from carbonic acid, carbonate. So it is formed from carbonic acid, which is a weak acid. Therefore, it's an example for a salt formed from a weak acid. So these are the examples for weak electrolytes, and many more examples are given in the textbook. You can learn from the textbook. The next is non-electrolyte. They do not conduct electricity in any state. In solid state or aqueous state or in molten state, they do not conduct electricity, and they do not undergo chemical decomposition, and they are covalent compounds containing molecules only. So you studied about strong and weak electrolytes. Strong contains ions only. Weak electrolyte contains ions and molecules, whereas non-electrolyte contains only molecules. Only molecules cannot conduct electricity. Example is distilled water, alcohol, carbon tetrafluoride, and many other covalent compounds can be given as example for non-electrolytes. So we have studied about electrodes. Electrodes allow electric current to enter or leave the electrolytic solution. So there are two types of electrodes, anode and cathode. Anode is positive electrode. So negatively charged ions migrate to the anode. Negatively charged ions are anions. They donate excess electron to the anode, and therefore anode is also called as oxidizing electrode. And oxidation takes place at the anode. Oxidation is loss of electron. So chlorine ion loses one electron to form neutral fluorine atom. Cathode is a negative electrode. Therefore, positively charged cations migrate to the cathode and gain excess electron from the cathode, and hence it is called as reducing electrode. Therefore, reduction takes place at the cathode. So example, sodium ion gains one electron from the cathode and changes into neutral atom, that is sodium atom. So we have studied about anode, cathode, anion, cations. Let's study about the characteristics of electrolysis. The number of electrons gained by the anode is equal to the number of electrons donated by the cathode. The products of electrolysis are formed at the anode and cathode itself. That is, when dissociation takes place of a chemical compound, it dissociates into positive and negative ions and then gets converted to neutral atoms. So the products are formed at the anode and cathode. Hydrogen gas and metals are liberated at the cathode. Hydrogen is a non-metal, but like metals, it is liberated at the cathode. So they are called as electropositive elements. Non-metals are liberated at the anode, and they are called as electronegative elements. Under mechanism of electrolysis, we studied about characteristics of electrolysis. Now we will study a comparison between electrolytic dissociation and ionization. I have not written the full definition here. Refer to the definition in the textbook. So electrolytic dissociation is a process due to which an ionic compound in fused or molten state or in aqueous solution state dissociates into ions by passage of electric current through it. Now, electrolytic dissociation is a process which takes place in electrovalent compounds or ionic compounds. It involves separation of ions which are already present. So, its an example is lead bromide. It's an electrovalent or ionic compound where ions are already present. There is only the separation takes place. That is, it dissociates to give Pb2 plus and 2 Br minus ions. So, electrolytic dissociation takes place in ionic compounds and there is only separation of ions which are already present in the ionic compound. Now, coming to ionization. Ionization is a process which takes place in covalent compounds. Note the difference which I have underlined. It involves formation of ions. Ions are not present here. They are in the form of molecules. Ions have to be formed. So, formation of charged ions from molecules. Example, hydrochloric acid. Hydrogen chloride or in aqueous solution, it's called as hydrochloric acid. It dissociates to give H plus and Cl minus ion. It's a covalent compound. So, ionization takes place in covalent compound. Covalent compounds do not have ions. They are in the form of molecules and so ions had to be formed from molecules. So, it is called as ionization. Very important question normally asked, difference between electrolytic dissociation and ionization. This is also an important part of the lesson, that is electrolytic dissociation of sodium chloride in molten state. Sodium chloride is an example for ionic compound. So, sodium chloride dissociates in molten states or in aqueous solution state. Here is the example to show in molten state what happens. So, solid sodium chloride is their ions already present in them, but they are held together by strong electrostatic force of attraction. That is, an ionic bond is present between sodium and chloride. So, this bond, if it breaks, then they get separated into ions. For breaking this bond, it has to be heated strongly. On heating strongly, it dissociates to give Na plus and Cl minus ion. So, in molten state, you find ions being present. Therefore, in molten state, sodium chloride is a good conductor of electricity. Whereas in solid state, it cannot conduct electricity because the ions are not free. Free ions are required for the conduction of electricity. Electrolytic dissociation of sodium chloride in aqueous solution. That is, sodium chloride dissolved in water. Water is a polar solvent. That is, it has charge separation. Hydrogen is slightly positively charged and oxygen is slightly negatively charged. This is due to the difference in their electronegativity which you have studied in chemical bonding. In water, each hydrogen atom develops a slight positive charge and oxygen develops a slight negative charge. So, when sodium chloride is dissolved in water, it dissociates to give Na plus and Cl minus ion. They are held by electrostatic force of attraction, but water is added to it. It gets separated into Na plus and Cl minus ion. This is due to the fact that the slightly negatively charged oxygen atom of the water exerts a pull on the positively charged sodium ion. A similar pull is exerted by the slightly positively charged hydrogen atom of the water molecule on the negatively charged chloride ion. Thus, sodium and chloride ion become free in solution. Next is ionization of covalent compounds. Example, hydrochloric acid. Hydrochloric acid is a polar covalent compound. Not all covalent compounds will undergo ionization. Only polar covalent compounds will undergo ionization. Example, we have ammonia and hydrogen chloride gas for polar covalent compound, but in gaseous state, they will not undergo ionization. They are non-electrolytes in gaseous state, but will ionize in aqueous solution state. When dissolved in water, they form a solution of hydrochloric acid, and ammonia solution will undergo ionization only in solution state, aqueous solution state. Now, let's study the ionization of hydrochloric acid. Hydrogen chloride gas is a polar covalent compound. which when dissolved in water, which is also a polar covalent compound, ionizes to form H plus and Cl minus ion. When hydrogen chloride is added to water, a polar solvent, a slightly negatively charged oxygen atom of the water exerts an electrostatic pull on the positively charged H plus ion of hydrochloric acid and thus combines with water to form hydronium ion. Thus, when hydrochloric acid dissociates in aqueous solution, produces hydronium ion and chloride ion. Conductors, there are two types of conduction. One is metallic conduction, the other is electrolytic conduction. For metallic conduction, metal copper is taken as an example. For electrolytic conduction, copper sulfate solution is taken as an example. So how electricity passes through a metal? It is due to flow of electrons. Whereas in an electrolyte, the electricity flows due to flow of ion. That's the main difference between electrolyte and metallic conduction. It is flow of electrons in metals, whereas in electrolyte, it is due to the flow of ions. The parent metal, that is the copper here, does not undergo any decomposition. So, the chemical properties of the metal are intact. There is no change in chemical properties. Metal copper remains as metal copper even after the passage of electric current. Whereas here, there is a decomposition, that is electrolyte copper sulfate decomposes on passing electric current and therefore chemical properties of the electrolyte also are altered. That is, it decomposes into ions Cu2 plus and SO42 minus ion. Therefore, there is a chemical property being changed here, altered. The third point, metals are good conductors of electricity in solid state and molten state because it is only electricity flows only because of flow of electrons. Therefore, they can conduct in solid state also and in molten state. Whereas in an electrolyte, they conduct electricity due to flow of ions. Therefore, they do not conduct in solid state. They conduct electric current only in aqueous solution state or molten state. Because only in aqueous state or molten state, ions are present. Ions are required for conducting electric current. So, coming to metals here, because there is no decomposition taking place, no new products are formed. Whereas in an electrolyte, there is decomposition of the electrolyte, therefore, new products are formed. We have studied about acid, bases and salts in detail in the last chapter. Now we will study about acid, bases and salt as electrolytes, how they are used as electrolytes. So, based on that, it is classification of acid, bases and salt into strong and weak electrolytes. You have studied about strong acids and strong bases. Strong acids contain only ions in their molecules. Weak acids contain ions and molecules in their solution. So, here it's the same like that. Acids, example here for strong acids are all mineral acids are strong acids. Hydrochloric acid, nitric acid, sulfuric acid. They are all strong acids. They are also strong electrolytes because their solution contains almost ions only. Acetic acid, formic acid, carbonic acid. Acetic acid and formic acid are organic acids. All organic acids are weak electrolyte, but carbonic acid is also a mineral acid, but it is a weak electrolyte because the solution contains low concentration of ions, or they contain ions and molecules in their solution. Now, bases or alkalis. Bases ionize in fused or aqueous solution state to produce hydroxyl ions. You have studied about strong bases or strong alkalis and weak alkalis. Strong alkalis contain ions and only ions in their solution. Weak alkalis contain ions and molecules. They dissociate to give hydroxyl ion as the only negatively charged ion. So here there are a few examples for strong alkalis are sodium hydroxide, potassium hydroxide, lithium hydroxide. They are all examples for strong electrolyte because they contain only ions in their solution. Calcium hydroxide, magnesium hydroxide, ammonium hydroxide are called examples for weak electrolytes because their solution contains both ions and molecules. It is same as what you studied in acids and bases, strong acids and strong bases. So here also you find strong electrolytes of example of acids and strong electrolyte example of bases or alkalis. The next is salts. Ionic salts ionize in fused or aqueous solution state to produce positive ion other than H plus ion and negative ion other than OH minus ion. This is what you studied in the previous lesson. So here you find salts of strong acids are strong electrolyte. Salts of weak acids are weak electrolyte. So how do you identify which is a strong electrolyte, which is a salt of a strong acid? So here are a few examples. Sodium carbonate in aqueous solution. Lead bromide in molten state, because this molten is fused state. This cannot be in solution state, so it is taken in molten state. So lead bromide is a strong, it's a salt of a strong acid. Copper chloride is also a salt of a strong acid. Silver nitrate is also a salt of a strong acid. So they're all example for strong electrolyte. And here we have sodium carbonate, potassium bicarbonate, lead acetate. They're all salts of weak acid. So therefore an example of weak electrolyte. That means their solution contain low concentration of ions and more of molecules, whereas strong electrolytes contain high concentration of ions only. You have heard about activity series. That is, the metals arranged in the descending order of their reactivity. Same as that, it is also called as electrochemical series. So here we'll study about how easily the metals lose their electrons. Depending on the ease with which the metals lose their electrons and form ions, they are arranged in a series known as metal activity series or electrochemical series. Here we have the electrochemical series of cations and anions. The arrangement is so done that the elements that ionize most readily are placed at the top of the series and the other elements in the descending order. You have both cation and anion. Potassium loses one electron to form potassium ion. Potassium ion moves towards the cathode, gains one electron with great difficulty to form potassium neutral atom. At the lower end of the series, we have example copper loses two electrons with great difficulty to form copper 2 plus ion. This copper 2 plus ion moves towards the cathode and gains electron readily to form copper atom. Similarly, silver, which is found at the bottom of the series, loses one electron with difficulty to form Ag plus ion but gains one electron moving towards the cathode, forming Ag neutral atom readily. The other concepts which you have to learn before going to learn about exact electrolysis of certain substances, you'll have to learn about selective discharge of ions. So in a solution of an electrolyte, you find both anions and cations. So there will be more than one anion and more than one cation. So there will be a preferential discharge of ions present in an electrolyte at a respective electrode depending on the electrochemical series. So you'll have to learn the electrochemical series by heart. Now, what are the factors which affect selective discharge? Now, based on what the selection of ions takes place? It takes place based on three factors. One is relative position of the cation or anion in the electrochemical series. Second is concentration of the ions in the electrolyte. Which ion is more concentrated? The third is nature of the electrode. There are two types of electrodes, that is active electrode and inert electrode. So with this, we'll complete for this class. The next class will study in detail about selective discharge of ions and factors affecting selective discharge. Thank you.